Good morning, geometry class. Hope all are doing well. And as we pick up on page 1119, we're going to quickly review some of the pages we did yesterday, page 24, page 28. We'll go through some of the things that we've learned, and then we'll get on to our new topic this morning, parallel and perpendicular lines. But before we do, let's pray, and then we'll get started in our class. Lord, give us wisdom. Without you, we can do absolutely nothing. Illuminate our minds. Give us the wisdom that we need to apply these theorems, these proofs, into learning geometry. We'll thank you and praise you in Jesus' name. Amen. All right, we're going to pick up on page 24. Look at our homework last night. We'll just do a couple by way of review, making sure that everybody's on the same page. We are, have your checkup scored, and then we'll go over those. If there's any problem areas, we'll go over the checkup tomorrow. But this time we're going to look at page 24 and page 28. Just before we get there, again, these formulas, you need to make sure you're memorizing these formulas. We have the distance formula between 2 points on a coordinate plane. So if the points have the same y-coordinate, the distance would be the absolute value of the difference between the two x-coordinates. And then the distance, if we have the same or x-coordinate, we have the distance would be absolute value, the difference of the y-coordinates. And then we have the distance of various coordinates, okay? Coordinates that are not the same. So that would be the square root of x squared minus x1 squared plus y2 minus 1 squared, x1 squared. Then we have the midpoint, the sum of the two coordinates divided by 2. You'll see the x plus 1, x plus 2 divided by 2. Y plus 1, y plus 2 divided by 2. That gives us the midpoint. Remember, the midpoint is, it divides a line segment into two equal parts. So we can find the midpoint of a line on our graph using the midpoint formulas. And then we looked at the slope of a line. The slope of a line is represented by m. And so again, m would be the difference between the y-coordinates over the x-coordinates. And so y2 minus y1 over x2 minus x1. We also learned what a positive negative slope is. A positive slope slopes up and to the right. A negative slope slopes up or down and to the right. So there's the difference. Then we have a line that is parallel to the x-axis. A line that is parallel to the x-axis is simply no slope. And then we have a vertical line that's parallel to the y-axis, and that is simply zero slope. So be sure you remember those. And then we looked at the graph of the equation of a straight line. We call this a linear equation. The standard form is ax plus by equals c. We learned that we can chart a straight line by using a table. We did that, and then obviously the x and y numbers must satisfy the equation, and that's this. And then we looked at the point slope and the 2-point equation. Both of those equations, if we have a set of points and we have a slope, we can find this equation by simply plugging in the set of points and the slope. That'll give us this equation. And then if we have a set of just 2 points, we can still find this equation by plugging in the numbers and solving. Now remember, when both of these, the point slope and the 2-point equation there, we want to come to the standard form. There's 2 rules that we need to remember when we come to standard form. The first coefficient must never be negative and must never be a fraction. So remember those 2 particular rules. And then last night we learned the slope-intercept form. The slope-intercept form. And again, we can use a table to find the line of a graph, but we could do something simpler, and that is simply the slope-intercept, which is y equals mx plus b. And so if we see something in this form, we can read the slope and the y-intercept, and then simply graph a straight line doing that. So again, straight line. We're going to continue with that theme, but let's quickly look at page 24. Our homework, we had to do the evens, 2, 4, 6, and 8. I'm just going to quickly do 2 of those. We'll do 2 and 4, making sure, again, just by practice, and everybody is on the same page. So, all right, we have points. We have 2, 0, and we have points 0, 5, okay? So let's quickly use the 2 points. Since we're dealing with 2 points, we're going to use the 2-point equation here. So y minus y1, so y minus 0, equals, okay, now since no slope is given us, we have to solve for the slope. So y2 minus y1, so 5 minus 0 over x2 minus x1, which would be 0 minus 2, times x minus x1, which is there. Okay? From there, now we're just going to simply do our math. All right? So from there, we got y minus 0 equals y. 5 minus 0 is 5. And 0 minus 2 would be negative 2. So we're going to just put this here, negative 2. And then we have x minus 2. Now what we want to do here, again, we want to read our slope and we want to read our y-intercept there. So now let's quickly see what we're going to do here. So we have y minus 5 over 2x times negative 2. We want to simply use the distributive property here. So let's first get rid of this fraction. I'm going to multiply by 2. So we have 2y equals, all right, these 2's cancel out here, so negative 5x minus, all right, and then we have negative times 2 would be there. So negative 5x plus 10, negative 5x plus 10. And then once we get there, obviously we want to get rid of this coefficient in front of the y because it's got to look like this. So no coefficient in front of the y. So then we're going to simply divide everything by 2. All right, so, oh, wait a second. I'm sorry. Stop that. I am completely confused. I am completely lost here. All right, I'm using the, all right, let me go back here. We're not looking for this equation. We're looking for this equation. So I got lost a little bit. So let's quickly go back here. Y equals, all right, negative 5 over 2. Okay, and then we're just going to multiply again, get rid of the fraction. So 2y equals negative 10. Okay, again, negative 10x plus, and then negative 5 times, oh, wait a second. I am really struggling. Okay, now I think I'm back. All right, I'm back. So thank you for your patience. I had one of those days today. All right, so now we want to get this into the linear equation, the standard form here. So in order to do that, I got to bring using addition and subtraction axiom of equality, I want to bring the 5 to the right and then simply leave the 10 here. So we have 5x plus 2y equals 10. And that should be your answer there. So forgive me for getting a little bit of confusion there. All right, so let's do the next one. Let's do number 4. I'm sure you guys could do pretty well without me confusing you here. All right, let's do number 4. Okay, so number 4 we have negative 2, 3, and then we have 0, 6. All right, negative 2, 3, 0, 6. Let's plug it into the 2-point equation. Let's come up with this standard form here. So y minus y1, so y1 is 3, equals, all right, y2 minus y1, so 6 minus 3 over x2 minus x1, which is 0 minus negative 2, times x minus negative 2. Okay? So all I'm going to do quickly, again, I will do long form, so this way you can understand the steps that we're taking. So we have y minus 3 equals, all right, 6 minus 3 is 3, and then negative times a negative gives me a positive 2. And then x, that becomes a plus 2. Now, again, anytime we have this fraction, we want to eliminate this fraction, so I'm going to multiply both sides of my equation by my common denominator. So 2y minus 6 equals, these cancel out. So 3 times x is 3x. 3 times 2 is 6. Now let's rearrange the equation. So obviously using our addition and subtraction axioms of equality, I'm going to subtract 3x from both sides. So negative 3x plus 2y equals, I'm going to use addition axiom on both sides, add 6, so we have 12. Now what's wrong with this? We cannot have a negative sign in front of the coefficient, so I want to multiply everything by negative 1. So all our signs change, so 3x minus 2y equals negative 12. Now, we can use this equation, we can make a table, and whatever these numbers are, x and y, if they satisfy this equation and equal negative 12, we would get a straight line, a linear line on our coordinate plane, all right? So 3x minus 2y equals negative 12. Now, let's go to next page here. We have, I'm going to skip down to page 28. Skip over to page 28. And then we're going to look at the slope-intercept form here. And again, this is easier to graph a line than it would be using the standard equation with a table. So let's look at that here. Page 28. Again, we did this for homework. So let's look at number 2. We have 5x minus y equals 13. We want to put it in this form here, all right, and then find out what the slope and the y-intercept is. So negative y equals, again, I want to get 5 to that side of the equation. So we're going to use the subtraction axiom. So we have negative 5x plus 13. We cannot have a negative sign here, so again, we want to multiply everything. So y equals 5x minus 13. Now, from here, we can read the slope and we could read the y-intercept. And from there, we can graph this. So the slope would be 5 over 1. So 5, right? 5 over 1. And then the y-intercept would be 0, negative 13. 0, negative 13. That's how you would read that. Number 4. All right, number 4, we have 7x plus 8y equals 26. Now, you see how it's in this equation here, the linear equation, it's standard form. So we could graph a line using this standard form. We would have to plug in numbers. We'd have to find 2 numbers, which can take a while to satisfy this equation. So an easier way would be the slope-intercept form. So looking at this, let's go. We have, all right, we're going to bring the 7x over to the right side. So we have 8y equals negative 7x plus 26. Okay, now from here, what we want to do is get rid of this 8. I'm going to divide everything by 8. So y equals negative 7 over 8x. And then 26 over 8. So 26 over 8. So we could simply reduce that to 13 over 4. And here's what our graph would be. So our slope-intercept, or excuse me, our slope would be negative 7 over 8. Again, what does that mean? So our y-intercept would be 13 over 4. And how you would graph an improper fraction, you would simply change it to a mixed number. Then that's how you would graph that. So our slope is negative 13 over 4, and then our y-intercept and our slope is negative 7 over 8, which simply means 7 units down, 8 units to the right. 7 units down, 8 units to the right. And that's how you would read that. So again, if you have an improper fraction and you need to graph that, change that to a mixed number, and then you find your slope from there. All right, so let's do number 6. So let's graph this. Okay, let me draw my coordinate plane. 0. Okay. All right. So from here, we have our equation is x minus y equals 5. All right. So let's put that in standard form. Again, we could just simply do the table method as well. So it's still the same method, but this could take a little longer. So the y-intercept is just a quicker way to find out what our coordinates are. So let's change this here. So negative x, or negative y, equals negative x plus 5. We're going to multiply everything by negative 1. So y equals x minus 5. All right, x minus 5. Now, from here, what's our slope? 1 over 1. It's 1, right? So our slope would be 1 over 1. Okay, and our y-intercept would be 0, negative 5. And that's where we begin our graph. So 0, -5 would be here on the graph. So 1, 2, 3, 4, 5. So 0, -5. From there, we're going to read our slope. From there, we're going to go 1 up and 1 over to the right. So 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, 1 up, 1 over. And there you have it. Get your ruler out, your straight edge. Graph that. We have a straight line. So we'll do one more together. Let's do number 8. All right, let's do number 8. So we have y equals 2. All right, so there is no, all right, we do not have a slope here. So our y-intercept is 0, 2, which would be right there. And since we don't have a slope, right, so it's parallel to the x-axis. So is that a 0 slope or a no slope? Very good. That would be simply a no slope. Very good. So basically, it would kind of look like this. Right? There is no slope, and we have a parallel line parallel to the x-axis. All right? So that brings us to tonight's class. We're going to look at page 29, parallel and perpendicular lines. Parallel and perpendicular lines. Notice the two lines in figure 5, all right? We're at the top of page number 29. These two lines seem to be parallel. The equation of the first line is y equals -1/3 x plus 3. And the equation of the second line is y equals -1/3 x plus minus 1. Since these equations are both in the form y equals mx plus b, we can see the slope of both of these equations. Now, what is the slope? So quickly, let me write this down. Y equals -1/3 x minus 1, and y equals -1/3 x plus 3. What do you notice about the slopes? They're the same. If our slopes are the same, now we have different y-intercepts, but if the slopes are the same, then the lines will never intersect. The lines on our graph would be parallel. So the same slopes, and again, if you look at figure 5, if we were to graph this, you will see that we have parallel lines. So the key, if we have the same slope, the lines will be parallel. All right? Well, the lines will be parallel. Let's quickly look. So look at Theorem 108. Again, Theorem 108 is something you want to know. And it says if two non-vertical lines are parallel, then they have equal slopes. And obviously, we can do the reverse of that, the reciprocal of that. And we could say if we have two non-vertical lines have the equal slopes, then they are parallel. All right? So let's quickly look at this. All right? Page 30. Looking at page number 30. Look at number 3. It says, find the slope of line AB and CD, then determine if the two lines are parallel. All right, so we're looking at number 3 together. Number 3 together, okay? So basically, how do I find the slope of a line? Okay, we use the slope formula. All right, now if the slopes turn out to be the same, then the lines will be parallel. If the slopes are different, then we would say no. All right, so let's quickly do number 3. So our points are, I'm going to say point A is 2, 3, and point B is 5, 0. And then we have point C is 1, 4, and point D is -1, -4. Okay, so I'm going to plug this in, and we're going to solve for the slope on this side, and then we're going to plug these numbers in and solve the slope for this side. If the slopes are the same, then the lines are, what, class? Parallel. Okay, so let's take our slope formula. M equals y2 minus y1 over x2 minus x1. All right, so let's plug them in here. y2 is 0. So 0 minus y1 is -3 over x2, which is 5 minus x1. Okay, so we have -3 over 3. So -3 over 3 gives me an answer of, if I reduce that, -1 over 1, or simply -1. Okay, Now, if this slope comes out to be the same answer, then we can conclude that the lines will be parallel. So let's plug these in here. So m equals y2 minus y1 over x2 minus x1. All right, so we're going to plug in here. So y2 is negative 4 minus 4 over, okay, x2 minus x1. So negative 1 minus, all right, 1. Negative 4 minus 4 is negative 8. Negative 1 minus 1 is negative 2. If we reduce that, the answer would be, okay, 4 over 1. Now, just simply by looking at this, number 3 here, can we say, all right, looking at here, are these lines parallel based on the information that we have? Remember, if they have the same slope, they are parallel. So this is negative 1, this is 4. If they're different, then what can we put there in the answer? Is line AB parallel, or excuse me, slope of line AB parallel to slope of line CD? What would you put there for your answer? No. Very good. That is correct. The answer is no. All right, so let's do number 4. You could do number 4 for homework, for practice. Let's look at the second section here. Write the slope-intercept form of each equation and determine whether the graphs of these equations are parallel. So, all right, now what we're doing is we have two equations. We have 2x minus y equals 0, and we have 3y minus 2x equals 4. What we want to do is we want to put them in this form. So, if they had the same slope, we could say that the lines are parallel. So let's put these in this proper form. So, all right, so for this problem here, what we want to do is we want to get 2x to the right side of the equation. So let's do that. So we have negative y equals negative 2x plus 0. Can't have negative sign, so we want to change that. So we have y equals 2x minus 0, which is basically, you can just leave 0 there. Y equals 2x. Now, so what's our slope for this equation? 2 over 1, or simply 2. Excellent. Okay, now let's solve for this one here. So negative, so 3y equals, again, I'm going to get x to the right side of the equation, so I'm going to use the addition axiom of equality. So 2x plus 4, divide everything by 3. So y equals 2/3 x plus 4/3. All right, now what's the slope here? This slope is 2 over 1. This slope is 2 over 3. So for number 5, is the answer yes or no? The answer is no. Very good. Again, different slopes. Different slopes give me intersecting lines, while as the same slopes give me parallel lines. All right, so do number 6 on your own there. Let's look down at the bottom of the page here. Let's look at the last page on the bottom of page 30. Write the standard form of the equation of the line that passes through each point and is parallel to the graph of each given equation. Okay, so let's look at number 7 together. Number 7. Again, we have our equation is 5x plus 4y. Let me erase this. All right, so 5x plus 4y equals 22. Okay? Now, write the standard form of the equation. So let's put this in standard form. Again, we're going to put this in the slope-intercept form. And then let's see here, okay? So let's see, write this in standard form of the equation of the line that passes through each point and is parallel to the graph of each given equation. All right, so for y, let's get 5 over here. So apply the subtraction axiom of equality equals negative 5x plus 22. Again, divide both sides, everything by 4. So y equals negative 5 over 4x plus, and we could reduce this, right? We know 2 can go in the 22, and 2 can go in the 4, which would simply be 11 over 2. 11 over 2. Now, with that, okay, we have 5x. So look at here. We have, right, 2 goes in 4 twice, 2 goes in 11. Yeah, that's correct. Okay. All right. So now that we have that, what do we have? So we could say that a parallel line must have the same slope. So if I have, all right, if we have, again, looking at here, we have point B is 5, -3. 5, -3. So from this line, we know, all right, we know that the slope, in order for a line to be parallel, it must have the same slope. Now let me show you. If I take these two numbers and plug them to x and y, watch what happens. Okay, so 5 times 5 plus 4 times -3, does that equal 22? So let's see, 25 minus 12, does that equal 22? So 25 minus 12 equals 13, which does not equal 22. So what do we have here? We know that in order for this line to be parallel to these points, it must pass through that y-intercept. So if I were to graph 5, -3 on my coordinate plane, and then I were to graph this point here for 11 over 2, all right? So what we would find out is, in order for these lines to be parallel, they would have to have the same exact slope, all right? They would have to be the same slope. So let me show you real fast. I'm going to put this in this form here, okay? So let me bring this over here. So -5, 5 over 4, x plus y equals 11 over 2. All right, let's get rid of the fraction here. So 5x plus 4y equals, okay, and 2 and 4, so we have 22. This equation here must have the same exact slope. All right, that's what they're doing there. You could do number 8 on your own. All right, let's close on page 31 and 32. So this is perpendicular lines. So in order to have parallel lines, what's the key? In order to have parallel lines, what must we have between the two equations? The same slope. Very good. Now, what happens if I get intersecting lines? So perpendicular or intersecting lines. Quickly look at the page 31 here. Theorem 110. If two non-vertical lines are perpendicular, then the product of their slopes is -1. You say, what in the world does that mean? So if I have y equals -1/2 x, where am I here? -1/2 x, plus 4. And then I have y equals -2x minus 3. Let's take the slopes. If I multiply the slopes and the answer is -1, we have a perpendicular line. Now remember, a perpendicular line forms a right angle. So let's take this, -1/2 times, all right, I think it's, yeah, all right, it's +1/2, okay, +1/2 times -2 over 1. When we multiply that, so we have -2 over 2, which equals -1. So if the product of our slopes is -1, we know that we will have perpendicular lines. Let me just say this at the very bottom of the page, page 31. The graph of two lines having different slopes whose product is not -1, they're just going to be intersecting. They'll not be perpendicular, but they still will intersect. So here, let me boil it down for us. If we have the same slope, we have parallel lines, correct? Good. If we have different slopes, they're just going to intersect. But if my different slopes multiply, if I multiply those slopes and I get -1, then the lines will still be intersecting. The only difference is we will get perpendicular lines. All right, so parallel, perpendicular. Let's look at number 3. Using the slope formula, find the slopes of line AB and line CD, then determine if they are parallel or perpendicular. All right, so let's using the slope formula. So, all right, the slope formula, y equals, m equals y2 minus y1 over x2 minus x1, all right? So let's quickly look at number 3 here. We're going to go point A is 2, -4. Point B is -2, 8. C is -1, -2. And D is 3, -14. So I'm going to do the slope formula of A and B and C and D. If the slopes are the same, parallel. If the slopes are, the product of the slopes is -1, they're perpendicular. If the slopes are just different slopes altogether, we'll have intersecting. So let's see, writing y2, so 8 minus y1 is minus -4 over x2, which is -2, minus x1, which is +2. All right, so we have 8 plus 4 over -4, and 8 plus 4 is 12 over 4, which we would have, right, -3, or -3 over 1. Same answer either way is fine. Now, let's do these two, and let's see if we get the same slope here. All right, so m equals y2 minus y1 over x2 minus x1. All right, let's plug these in here. So y2 is -14 minus, is that -2? Let me see here. Yes, all right. -2 over x2, which is 3, minus -1. All right, so -14 plus 2 over 3 plus 1. Okay, -14 plus 2 is -12 over 3. We reduce that, and what do we have here? This should be 4. Very good. -3. So for number 3, do we have parallel or perpendicular? Parallel or perpendicular? Quickly, is line AB parallel to line CD? All right, the answer is no. Very good. They are not parallel. Very good. They are not parallel. Very good. So let's see here for number 3. Okay, let's look at number 5, and we'll close class with number 5 here. Okay, oh, so did I say they weren't parallel? They are parallel, right? They're the same. So, I'm sorry, they're the same. Right? Same is parallel, different is perpendicular. Forgive me there. All right, let's do one more in closing. Let's do number 5. All right, we're going to graph them, and then we'll stop here. All right, so we have our graph. Let me just do our coordinate plane here. Simple coordinate plane. 0. Okay? All right, there's our y-axis, here's our x-axis. All right, we have y equals 1/4 x minus 4, and y equals -4 x plus 4. All right, so what's our slope here for the first problem? All right, we have 1/4, and our y-intercept would be 0, -4. And then for this one, our slope is -4 over 1, and our y-intercept would be 0, +4. Now I want you to notice something. We're going to graph this quickly, but notice the slopes. 1/4 times -4 over 1 is -4 over 4, which equals -1. So if we have different slopes, they are different, and the product is -1, which they are, we know that the lines will be perpendicular. Let's graph them together. All right, so let's start here with the first one. So 0, -4 would be right there. All right, from there we're going to go 1 up and 4 to the right. So 1 up, right there, right there, right there. Okay, there's our line. So what I like to do is I like to write my equation right next to there. Wrote the wrong one. So this is y equals 1/4 x minus 4. Okay, now let's graph the second equation. So 0, 4 would be up on the top here. 1, 2, 3, 4. From there, we're going to go 4 down, 1 to the right. Okay, so 1, 2, 3, 4, 1 to the right. 1, 2, 3, 1 to the right. All right, and then 1, 2, 3, 4, 1 to the right. And notice now we have perpendicular lines. Perpendicular lines. The reason being is if the slopes are reciprocals of one another, then we will have a perpendicular line. If they're just simply different slopes, then they will have intersecting lines. So quickly as we close, I want you to do number 4 and number 6 for homework, and I'll be ready for tomorrow. Now what I'd like for you to do, just quickly by way of review, how do we know the lines are parallel? Same slopes, very good. How do we know if the lines are perpendicular? The slopes are reciprocal of one another, reciprocals of one another, so the answer would be -1. How do I know if the slopes are just going to be intersecting lines? The slopes will be different. Very good. So this slope-intercept equation is our simplest way to graph a straight line. Tomorrow what we're going to do is learn how to graph circles on the coordinate plane. All right, so make sure your homework is done, get that turned in, and I will see you tomorrow. Have a blessed day. Bye-bye.